Welcome to another Flutter Embedded tutorial where we use the Raspberry Pi as our single-board computer as part of a complex IoT system. By leveraging the power of Flutter, we can quickly develop complex IoT embedded systems that require a complex touchscreen user interface. I assume that you already have your development system set up. However, if you don't have your equipment yet, please check out the YouTube description for the equipment list and links. Please note that I get a small commission for each product you'll purchase through the links, and this helps me to keep more content coming. In this part of the UART tutorial series we will cover these topics. How to install the terminal program Putty on a Linux desktop computer. The reason for using Linux is that the syntax for command line is very similar to the Raspberry Pi. In addition, it can be a bit easier and less troublesome than other computer operating systems. After installing the Putty terminal program, we will go through the setup needed for our future Flutter IoT app using the system UART for serial communication. While doing the setup, we show you how to fix a Putty app error concerning the system's fonts. Next, we will show you how to connect a TTL to USB cable and do a loopback test. Please check out the YouTube description for the cable we recommend. Be aware that different cables may require different setups that are not covered in this tutorial. Finally, we will send data to the Raspberry Pi and verify the data, and then send data from the Pi to the Linux desktop computer and verify the data. These steps are critical to perform before coding our Flutter IoT app and will eliminate any guesswork during debugging of our app. Now that we have introductions out of the way, let's get started with the tutorial. It is assumed that your Linux is up to date. Open up a new terminal session and type in sudo apt-get install followed by a space and a dash symbol, and then type in a lowercase y followed by a space and the word putty. If that was all a bit fast, pause the video and type in the syntax as shown on the screen. You may be required to enter your password. As you can see, the Putty terminal program is now installed. Clear the screen, type in the word putty in lowercase, and then press the enter key to start the program. Make the program full screen, select Sessions, and then select Serial with speed set to 9600. Change the serial line exactly as shown. I have already created a saved sessions file as shown. This is where you must save any changes to your Putty setup. This will allow you to reload your setup when you start Putty. Now select Fonts and follow along. We will fix a Putty bug regarding the system fonts setup. If I move too fast, simply pause the video, enter the data, and then continue on. Now that we have fixed the font bug, let's select the connection serial as shown, and then make a few changes. Change the flow control to none. Check that all of the other settings on your Putty setup are the same. Now go back and select Session as shown. Select your saved sessions file and then select Save to save your changes. Exit the Putty program by pressing the Cancel button at the bottom of the screen. Restart the Putty program and then make full screen. Select Session and then select your Save Sessions file. Now load the settings file. After loading we will check the serial settings, font settings, and session settings to make sure we have no errors. Now that we have installed and set up our Putty program, it's time to move on to the next part of the tutorial. Now it's time to do our Linux computer loopback test. Here is an overview of what we are going to do. Before we connect to the computer, we will review the setup. First, we have a loopback wire connected as shown. Pause the video to get a good look at the pin and wire connections. I have blown up the image to show you all of the pinout descriptions. For the loopback test, we will only use the TX and RX pins. Oh, just a minute, my director is telling me I forgot to remind you to plug in the USB cable. Now let's move on to the next part of the tutorial. Make sure your TTL to USB is plugged into the computer. On the Linux computer, open up a terminal session, and start the Putty program. We can ignore the errors shown in the background. Load your previous settings, and verify everything is correct. Everything looks okay, so we can open up a Putty terminal session. Go to the bottom of the Putty user interface and click on Open to start the session. I am going to make this a bit easier for you to see on your screen. That's about right. Now when you type in a character from your keyboard, a data signal is sent to the converter transmit pin and loop back into the converter receive pin. This data is then echoed back onto your terminal screen. This concludes our loopback test and ensures that our future Flutter app will work. Now to the fun part. We will get ready to wire up the Raspberry Pi to the TTL to USB cable and then connect the converter to the Linux computer using the supplied USB cable. Here is a detailed pinout of the converter module. We will only be using the transmit pin, receive pin, ground pin, and VCC pin for the connection. Here is an overview of the entire data connection setup. I have expanded the wiring diagram to make it easier for you to see. Please pause the video if you need more time to understand the schematic. Now that the Raspberry Pi to Linux computer are connected, my assistant and I will do the data test. Currently, my assistant is starting a Putty terminal session. She is asking if the critical errors mean anything. Thankfully, we can ignore them for our tests. Looks like she is double-checking all of the settings. That is a great idea since most issues come from the wrong settings. Looks like she is about ready for me. I will go to my Raspberry Pi development system, open up a new terminal, and start a Putty session. Now when I type on the Raspberry Pi in the Putty terminal window I have echo off, so I will not see any characters. All of the data I am entering, however, will be transmitted to the Linux computer using our UART serial connection setup. The reason we did the loopback tests on the Raspberry Pi and the Linux computer is to make sure that when we did this test we would have no issues. That concludes our first test by sending data from the Raspberry Pi to the Linux computer. For our last test, I will send data from the Linux computer to the Raspberry Pi. My assistant will start a Putty terminal session on the Raspberry Pi and show it on the big screen. She is just about finished double-checking the settings, and will open a Putty terminal session to receive data from my Linux computer. I better get moving and start a Putty terminal session on my Linux computer. On my Linux computer, I don't have echo turned on, so the characters I am entering only show on the Raspberry Pi Putty window. Success! My assistant's Raspberry Pi development system is receiving the serial data from my Linux computer. This wraps up our Raspberry Pi to Linux computer setup and test. Stay tuned for our next YouTube videos that will dive into developing our Flutter app to handle serial data communications. Smash the like button and subscribe. See you in the next tutorial.